Let's make our examples a little bit tougher. We're dealing with x's and y's all the time. You're not going to get a binomial that's just strictly x's and y's. Take a look at this. Ta-da-da, ta-da-da. Oh my goodness, what do I do now? Real simple. Isn't the 2a replacing the x? Isn't this minus 1 replacing the y? Guess what? The rest of it is exactly the same. What do I mean? What are you talking about? So instead of using x's and y's, now use 2a's and minus 1's. Huh? Okay, watch. You'll love it. Trust me. Okay, so this is to the power of 4. So again, you can either use Pascal's triangle. Let's just use Pascal's triangle real quick. Okay, so there's to the power of 0. There's the power of 1. There is the power of 2, right? There is the power of 3. There is the power of 4. And that's the one we want, right? Okay, perfect. So you know what I'm going to do is I'm going to get rid of all of this Pascal's triangle stuff. So that's why I suggest maybe doing this on a scrap piece of paper. And here's our coefficients. 1, 4, 6, 4, and 1. Now, remember what happened with these guys, though. Remember, if this was an x, you would start with x to the 4 here. But it's not x. It's 2a. So in other words, this is 2a now to the power of 4, which would mean that this is now 2a to the power of 3. This would be 2a to the power of 2. This would be 2a to the power of 1. And the last one would be 2a to the power of 0, which is a plain old 1. Isn't that wild? You can do this with whatever coefficients you want. Here we go. This guy over here then, if you remember, is a negative 1. So this one would be negative 1 to the power of 0. This would be negative 1 to the power of 1. This would be negative 1 to the power of 2. This would be negative 1 to the power of 3. And this would be negative 1 to the power of 4. Oh my goodness, this is just too much fun. Right. Okay, so the hard part is now expanding this. Well, wait. 2 to the power of 4 is 2 times 2 times 2 times 2. 2 times 2 is 4. That's 4. Oh my goodness, that's 16. Since we did that on scrap paper, let's just get rid of that. Okay, so this would be 1 times 16 times, a to the 4. Oh, that's easy enough. This is 16a to the 4. Oh, that's sweet. Plus, okay, here's another tough one. This is now 4 times, what's 2 cubed? Oh, I know that one. 2 times 2 times 2, that's 8. A 3, but now I got this minus 1 here. What's minus 1 to the power of 1? That's minus 1. Changing this from an addition, surprisingly enough, to a subtraction because of that negative. 4 times 8, 32, a cubed. So you mean that binomial theorem will even look after the positives and negatives? Yup. Okay, check this out. This is 6. Oh, I know it's 6 times 2 squared is 4. A squared. But minus 1 squared is just positive 1. Oh, interesting. Okay, I know 6 times 4 is 24, but it's positive 1 now. So this is positive 24a squared. Nice. Nice. Okay, let's keep on going. This is 4 then. Okay, it's still a plus. It's still a plus. There's the 4 times 2a. It's to the 2a is to the power of 1. So this is 4 times 2a times, negative 1 cubed, which you know is just negative 1. So this is now going to change this to a minus. 4 times 2 is 8a. Beautiful. And then the last one. Oh, this is really tough. 1 times, look at that, negative 1 to the power 4. 1. So what's your answer? 111. No, it's not. It's 1. Isn't that wild? Look how beautiful that is. That is just so incredibly cool. Now, if perchance you're asked to do what this part here says, can you write this exact same expansion out now instead of using Pascal, using combinations? Of course you can, because remember, that's your choose. So 4 choose 0, 4, choose 1, 4, choose 2, 4, choose 3, and finally 4, choose 4. But I want you to see even more of a pattern going here. Folks, look back here for a second. Look back all the way back here. Okay? Right? Look at this pattern. Right there it is. Think about the pattern. Look, the coefficients are 1 because that is choose 0. And then the next coefficient is going to be 4. Why? Because this will be 4 choose 1. And 4 choose 1 always matches this. Look, 4 here, 4 here. Look, they're symmetrical. 1 on this side, 1 on this side. 4 and then 4. I mean, they're always, the second term is always going to match that power. So check this out. Okay, let's go to here then. So 4 choose 0 is going to be 1. 4 choose 1 is going to be 4. Go to the symmetrical side. That's 1. That's going to be 4. The only thing that you got to figure out here now is 4 choose 2. So bring up the calculator and just do 4 choose 2. Well, I just have the same number here from last time, so I'm just going to steal it. And I'm going to just change these numbers here to 4 choose 2. Works out to be 6. So you don't really need to write out Pascal's triangle in order to figure this out. You could just use the chooses. And then again, this would be 2a to the power of 4, 2a to the power of 3, 2a to the power of 2, 2a to the power of 1, and 2a to the power of 0, which is just 1. And then go again with this guy, realizing that your second term is not just 1, it's negative 1. So negative 1 to the 0 would be this guy. This guy would be negative 1 squared, negative 1 cubed, negative 1 to the power of, oops, missed one. 0, that should have been 1. Apologies. 2, 3, and negative 1 to the power of 4. Okay? It works out really, really well, and that will give you exactly the same answer as I had right here. Some people like writing out all of Pascal's. Some people just go right directly into the choose. Hey, you choose.